Okay, good morning. Hello, everyone. Welcome to our next meeting. Now we're doing our weekly Subspace protocol substrate review, backend review. So today we're going to cover three main topics. Nazar is going to cover the many PRs he's been submitting lately for changes to the core protocol. Ozgun is going to give an overview of the work he's been doing on the farmer side, and then we will have some time to review palette feeds and maybe talk about the relayer a little bit with Serge at the end. Anything else major we need to cover that I'm missing? Okay. All right. Nazar, we'll let you go first. And I'm actually gonna turn my video off because I am, oh, what's the matter? Why'd you raise your hand?
Accidentally.
Okay. I'm gonna turn my video off because I'm starving and I need to eat. I don't want to subject you guys to it, but I'm gonna be listening.
I think you should be able to see this. Can make it
Yes, we do.
bit nicer. Okay, so this is the first big update that I did since our last call, I believe. Maybe there are more, actually. It was Monday. What was this? I think we talked about subspace consensus, right?
Yeah.
So the next thing after that was, so this subspace upgrade was pretty simple. There was one major drawback. It was only recommitting to pieces when the salt changes. So basically, when you start and you have salt 0 and 1 from Genesis, you will not have any pieces, new pieces added to your effective plot until the third eon. So when salt changes to 2, and even then it's already outdated. So this pull request changed that, and we now have both plotting and recommitments happening in parallel in the background all the time. So all of the pieces that you plot, they will, as soon as possible, be commitments will be added for them, and they will be participating in the solving right way. So I guess the first change was what? Yeah, basically I had to rewrite the implementation completely. It was kind of awkward to use, and it was not really designed to be extended. So I removed everything related to the commitments from the plot implementation, so minus 480 lines of code. And I created another data structure instead. And that, yeah, and this commitments was like a submodule. Now we have just this, which is data structure, which has, besides constructor, it has a method. What is this? Wait, commitments. This is the one. So you basically have a method to create a new commitment. This is when the salt updates and we need to recommit everything. And then as we move on from there, we have a method, find barrage for searching, of course. And we have another method, which is probably not this commit. This is just refactoring of the old functionality. Okay. So basically we have an alternative implementation of the same thing. And the second one added the ability, I believe, commitments. The ability to create a commitment for particular pieces. So as we've plotted another 10 pieces, we can create commitments just for those, for all of the salts that are relevant and not outdated by that time. So there's that, and corresponding tests. And there was some cleanup after that. So this makes it really usable. It really works pretty well. The next big, any questions here? I don't think it will be worthwhile go through all of the code every line. unless you want to. Okay. The next one is we have palette feeds and we put some data, but there was no way to retrieve the data. Like there was no way whatsoever. And even though we don't have at this point an API to do that, we already have mappings for retrieving data with this this update. So the first commit was I've added some data structures which will be useful for retrieving data. I've added them to Subspace core primitives. So we have a block object data structure, which basically says where is the piece of data that we are interested in within the block. And we have...
Let's also interrupt. Just to make sure I understand correctly. We had no ways to retrieve data because we were using Spartan and, we were using not useful storage, and now we are using useful storage, so we have to retrieve data back. This is what we are talking about?
After upgrade to to Subspace, we already store useful data. But we don't have any information about where is your data within the whole history of the blockchain.
Okay,
like
this is solving the
problem. Gigabytes, but where are the data? No one knows.
Okay.
Like you can technically go through every block and you can like decode the block and decode transactions and then figure out what transaction it is. And if it's the transaction that you want, you can retrieve data from it, but it's like not efficient.
Yeah.
It's not gonna work. So I had to create this mapping where Farmer will store like a small database which says this hash of the object is there, basically. So this is the data structure which says where the data is within a block. And we have another data structure which basically has a list of those objects for a particular block. So we have a block, we have a bunch of objects in it, maybe zero, maybe many. Then we have similar data structure for a piece. So this is like already archived, erasure coded everything piece. Where are the objects there? And we have a similar thing which basically says what are the objects which start at this piece. It may not fit exactly in this piece, but at least it starts here, and you can figure out everything from there. Then I went into the palette feeds, and I've added this method, which I can probably show it like this, which basically takes an extrinsic that belongs to this palette. It can be created, can be put. We have only 2 of those right now. It takes data from it. And if it's like a put extrinsic, then there is useful data there. So this is our field. And it basically reverse engineers the scale codec and figures out what is the offset of that data within the extrinsic. Okay. So the encoding, I will probably do it once. Basically, the encoding is like this. We have an enum. So this is 1 byte for the discriminant. It can be up to 255, from 0 to 255 in scale codec. Then we have the first field is actually data, which is convenient for us. And that is a vector. So there will be an offset for the data length, which will be scale encoded in compact form. So we need to take that many bytes. So we take the data length, and then we encode it in compact form. And then we know what is the length of the length encoding in bytes. And then we have +1. What is this? Right. So the first field is actually field ID. That's why we have the length first. Then we have encoding, and then we have the +1 for the discriminant, which is fixed. So this way we can basically figure out what is the offset against encoded version of this extrinsic, where is the data starts. And then we add another field, how long is the data, okay? And we can return it. And then this thing is used in the runtime. So we have runtime where we have, well, I can show you the other thing first. So I had to add another runtime API in SP consensus POC at this point. Extract block object mapping. This basically is a method which anything like in the client can call with the block, and it should return an object where there is list of mappings in that block. Okay, and then runtime implements that method. So it has this, and then it just calls another function because this is within the macro. It really is bad for IDE to help you with autocomplete and stuff. So that's why I've created another function with the same name. And this is where the implementation is. I'll probably also show it like this. It's called, okay. So what we have here, we have a block, and then we have an empty list of things. We have some base offset because we know that the block will start with the header where we don't have data, so we can just subtract that. We will have an encoding of all of the extrinsics because there are many. That is also of some length, so we can subtract that. And then we basically go through every extrinsic. We have some additional offsets. I will not go through all of them. But at this point, we have only one palette and that can store data. This is palette feeds, which is why we are checking if a particular extrinsic we are looking at is belonging to that palette. If that is the case, we call that method I showed you before, that will return us either this is the extrinsic which puts some data or it isn't. And then we can add a new object. If it is, we can add a new object with correct values into our map. All of the offsets and sizes, because we don't have objects anywhere near 16 megabytes, we have actually 24-bit length to save some space instead of 32 or 16, because 16 is not enough, 32 is kind of wasteful a little bit. And we basically loop it over and over again, and we collect all of the mappings. So this is how we know what's inside of the block. So then during archiving process in the client, when we have a new block, we can basically go into runtime and extract all of the objects for that block. And that will be used later when we archive segments. It will be implemented into later commit. So this is basically what this first commit does. Any questions so far? Cool.
Actually, I have a question and a comment, Nazar. So one thing I just realized is that we're probably going to need to eventually extend the storage API, or the notion of a put, to have a feedless put or just a dumb put, like a very cheap, low overhead put.
Yes.
Where we can just add data in, and it's assumed that the client always maintains the metadata about it.
That will be implemented in this method. So right now we are going through all of the extrinsics. We only care about feeds, but we can also add another one here. So this will be a match statement instead of if, and we will have another implementation in that particular palette, whatever it is. So this is made in such a way that it can be extended. The rest of the system all the way further doesn't care how blocks are parsed.
Great. Okay. Awesome. And then the other thing is, I just wanted to make sure everybody's clear here. Like, Subspace is at the end of the day like an object storage. Like this, the storage layer of Subspace is object storage, right? So when we're putting like Kusama blocks in, these are objects, and we need to track these object IDs because the farmers are going to maintain this index of, like, client says I want object. Well, how does the farmer get the object out? So they have this table. So right now the table is just literally like a full hash table of all the object IDs and then what the mapping is into the blockchain history. As we upgrade the farmer from like this full replica farmer to a distributed farmer, that's going to be a part of the distributed hash table. Basically, this whole hash table is going to be segmented out across all the nodes on the network. That's much later. That's, you know, maybe a month down the road before we have that. But that's what Nazar is laying the groundwork for here.
Okay, let's move on. So the next one was some kind of preparation. Let me see. Yeah, so we have a few things here, actually. So there is an archiver which was previously having this data structure, which is segment item, which is an enum of different things that can be put into the segment. But now we not only need to store the bytes of the block, but we also need to know what kind of things are in that block. So that's why it was upgraded to this data structure where we have object mapping. It's done this way, a strange way with doc hidden and codec skip, such that when we encode, this information is not encoded. We only encode the bytes that we care about, and this is the same as this in terms of encoding when you skip that field. It's identical. However, we can still keep track of this while we are archiving during the process. So this is why this strange thing. We have the data structure here, which is imported that we saw before with the mapping for particular block. And I had to update a bunch of things in the implementation of the farmer of the archiver to just carry those things over all the way through, but it's not actually used yet. Okay. On the yeah, and I've just added dummy values like default for tests so that they compile. On the farmer side, I did some minor changes. Yeah, I've prepared that the API that allows you to get the block from the node, like every time we want to request it, it will not only send the block, but also this mapping for the block. So the farmer can also autonomously recreate the same kind of data structure on the archiver side of things. So this is not very interesting. And on the client side, we have this object mapping, and we send it to the archiver, basically. It's not used in archiver yet, but it is sent to that. So we have one that is for initial state, and then we have the other one, which is while we are plotting blocks as we do normally. So we just have a block encoded, and we have a mapping alongside of it. So this is just a preparation. Then there was actual implementation of translation from those offsets within the block to the offsets in the piece as it is sliced into segments and pieces. So this is a pretty massive change in the archiver. It will be probably hard to explain here. All you need to know is that on input, we have blocks. We have mappings for them. At the output, we have pieces and the same mappings, with the caveat that if some block was sliced in the middle, then the data will be like carried over the edge as well. And when archiver, yeah, there is a change. So when archiver returns archived segment, did I change it? Yes, I did. So when we have this data structure, which is archived segment, we had root block and pieces. Now we have another field, which is object mapping. There is, of course, a caveat. The length of this is half of the length of pieces, because in pieces we have data shards and parity shards from ratio coding. Hence, we only have mapping for the data part. The parity part is not accounted for because it's like special form of data. It's not directly retrievable. And all of this basically is done just so we can create this object mapping data structure. And then what we have here, on POC side, we need to send that mapping to the RPC side. And then on RPC side, we need to send it over to the farmer, so we have the same field as well. And on the farmer side, I don't think there are any changes. No. Okay. Then I've added just tests for all of this mess. Yeah, I think implementation was fixed by then. I just added a bunch of cases that recreate the kind of mapping that we want. So it just creates this manual, like offsetted object. And then we have a function which takes blocks and their mappings, and then it takes pieces and their mappings, and makes sure that if you go to the particular offset of a piece, the slice that we get is the same as if we go to the block and takes the same like corresponding offset. So the pieces, the actual data in both places is the same. So that means that mapping was actually done correctly. We do not have tests for the transactions yet, and we do not have some later tests, but I did actual manual testing, and I made sure that it actually goes correctly. But this is something that can be improved. And then the global mapping database. This is something that will be used by RPC to actually retrieve the data. So we have a new data structure, which is object mappings, which basically allows you to either retrieve data by the hash of the object that you want to retrieve, or you can store a list of objects by their hash and global object data structure. I will show you that data structure right now. It's in primitives. It's kind of similar data structure, but now it has a piece. This is like the index in the whole history of the blockchain ever. And then the offset within that piece, and then the length of the data that we care about. The offset here is U16 instead of 34-bit, because the piece itself is only 4 kilobytes, so it doesn't make sense to use anything bigger than that. And then we have some methods to conveniently get U32, more convenient, integer kind, and some encoding. Yeah, pretty straightforward. Then on the farmer side, this is just deleting it if you want to erase. And then this is just some references. Yeah, on the farm, we create the database, just like we create commitments database in the plot itself. And then this is just a call change. Yeah, and every time we have something that is archived, we also get object mappings. So we have a piece, we have an index, we have pieces themselves. There can be many. We have object mapping, and then this function will basically translate those mappings for a particular piece to mappings in the global history, because here they are starting from 0, but we need to start from a different offset, and the struct is slightly different for global object comparing to this. So this is why there is a utility function which translates them. So every time we archive something, we also store object mapping. So at this point, we have a data structure which allows you to retrieve archived things. 2 steps necessary to get use of to use it. First, we need to have RPC server which will be able to respond to queries. The other one will be to actually go retrieve a piece, start reading it. If there is not enough data, retrieve the next piece, and so on until we retrieve the whole data and return it. So there will be like a little bit of work, but we already create all of the necessary metadata about that, so we can add that functionality later without breaking or changing anything. It's already all done. And I have moved all of those data structures in the primitives to a separate module because there are many of them. So I just removed it from here and copy paste it in here. That's it. And that's it. So at this point, we have mappings, which is nice. Any questions so far? It took quite a bit more time to write and to explain.
Yeah, my question, what docs hidden does exactly?
When you generate documentation for the library, like on docs.rs, it will actually skip that field or data structure from documentation. So it will be there. You can actually call it, but it will not show in autocomplete in IDE. It will not show in the official documentation. It's just hidden.
Okay.
From docs.
Thanks.
It's usually used for something that is like not official API, and in Rust it will like IDE will actually respect that, and it will not show even in autocomplete. So if you type the whole method and like open parentheses, then it will show that it is actually something useful, but you will not find it otherwise. This is because the data structure it's actually will be used for decoding, but it will have like an empty default field for the mapping, so we'll not know about it and not care. And the vectors which are empty, they are also not heap allocated, so it's fine. And then I translated to preparation for the testnet. So the first one was to actually replace all of the POC and Spartan mentions to Subspace. I also did some changes around location of things. So I renamed Subspace Codec into Subspace Solving. Why? Because I added to Subspace Solving some more stuff. Like this, we can take a look at here.
Hey, quick comment on that, Nazar. I saw your response to what I wrote. Would it be possible for us to not just decouple codec into a submodule and then have solving that imports that, so that we can try to keep because codec is like a layer below prove verify. Like prove verify is constructed from the codec itself, and the codec is used for more things than just prove verify. So I'm just wondering if maybe that's a way that we can have some naming convention that fits in within the architecture.
But codec is not used for anything other than prove verify.
What about get piece? Decode?
Well, yeah. I don't know. This is the best name that I came up with at that point. I'm open to suggestions. Just something that made sense to me at the time. Yeah, so it's just a bunch of refactoring. So we had this SP consensus Spartan, which we basically no longer need. So there were some data structures that were moved around. I've added HMAC implementation into the primitive scripto. I've added the isCommitment valid and create tag, which were copy pasted between farmer and the verification, and some of the other things like that. So it's just mostly re-imports from different places. I've also changed to Rust 2021 edition. We are using nightly. 2021 will be unstable by next release, so we can safely use it. The primary difference is that you no longer need to import try into and try from. That's basically the only major thing in the code base so far. But there are some other things which we are not using yet.
Can I ask something on that?
Yes.
Like after the changes, IDE, IntelliJ IDEA, shows in commitment rs, try into is not defined. Do you want to import? But I do not import it, and when I run cargo test or cargo clippy or cargo run, blah blah blah, it works fine. So why does IDE does not identify it?
Counter question: do you have the latest version of it? Because it shows fine for me.
Yes.
I am using nightly, but it's working fine for me.
Yeah,
So
let's
maybe
discuss it after this meeting. Probably it's not related to code itself.
Okay, maybe next update will take care
of
it.
Maybe.
Because I'm on nightly primarily. Of nightly of the plugin, I mean. Then we had this awkward situation with the farmer ID, which we thought was the public key hash, but it's actually not. So just to avoid different miscommunication in the code, I basically renamed all of the farmer ID to farmer public key. It's kind of verbose, but it delivers the point. And also I made sure to use farmer public key hash consistently across the whole code base and documentation, which is again very clear what it is. And yeah, just mechanical mostly. And we had ability to generate global and local challenges. They are again were duplicated between the farmer and the client. So I just made sure to have those in here in the subspace solving as re-exported functions, so we can reuse them. And I also get rid of the ring dependency, which is like a bigger one. We are using the SHA-2 and HMAC libraries, which are very small and NoCD compatible as well, so it's nice. Yeah, this was the first part. Any questions here? Cool. And the next one, I basically went through the crates one by one, and I renamed all the Spartan and POC mentions into Subspace. It's a lot of changes, but no like logic change. I updated documentation in some places. So now we are like officially Subspace, and not a mix of everything. That also impacted API slightly. For instance, when we are talking about the farmer, when we go to the messages, there's so many files. Farmer here. So these methods, they were POC. I changed them to Subspace, and we also had here proposed proof of space. I changed that to proposed proof of replication. We have proof of replication in some places. We have proof of space in some other places. We have proof of storage still in some yet another places. We really need to get down to the single truth and like one way to call it. It was quite challenging. So this was the second
So does that
part.
mean we're calling everything proof of replication across the board right now?
It's a mix of replication and storage. I think storage is used more, actually.
Okay. Technically,
it wasn't wrong before.
Yeah.
It's not wrong now. It's just we need to stick to something.
Well, there might actually be a difference between the two. It just depends on how it's implemented. So the proof of replication is like a primitive from which a proof of storage is derived. So at a consensus level, it's a proof of storage. So like with the witness, basically.
Mhm.
But if it's just like the sloth codec decoding, but I don't think maybe there's not a place where we have it where it's just that isolated. So maybe we should use proof of storage across the board.
I really don't care. We just need to stick to something.
It's probably better. I mean, yeah, it's probably better to call it a proof of replication just across the board, because that's what we do in a lot of our, like in the white paper and documentation, is we use the term proof of replication.
Okay. Yeah, then I just went through all of the readmes that we have and Docker files, which were copy-pasted blindly from the old repositories, and they didn't work, honestly. And I changed all of them, and they're slightly simpler. They're slightly more efficient because you don't copy files over that are irrelevant. And I made 2 Docker files at the root. One is Dockerfile node. The other one is Dockerfile farmer. It's moved somewhere here. And they build 2 images. I updated readmes in many places, sometimes significantly, to remove all of the updated steps regarding the plotting phase. That is no longer a thing as a standalone process. Basically prepared such that someone can go and run it. And at this point, I build the images. So if you go to the README, I think somewhere under node, maybe this one. Probably not. We see Dockerfile. Yeah, Subspace Labs, Subspace Node, and Subspace Farmer are the names right now. This is also merged, and the next one was not merged yet. It was approved at some point by Ozgun, but I had to put another commit. This has the license for GPL3 for the node and the runtime for it. I moved node and runtime under crates. They are now called crates/subspace node and crates/subspace runtime. I cannot find it here. And they are renamed correspondingly. And then I added testnet chain spec, so I can show you here. It's similar to what we had before. Yeah, lots of documentation updates at this point. So we basically have this blob where we have subspace testnet, we have an ID for it, and we also have a protocol ID here, and I also named in the runtime somewhere subspace here instead of template. And I believe there was yet another place. Yeah, substrate node was here. And I put the invitation link to our testnet channel on Discord. This is like support URL when something crashes. And you can actually specify like -- chain testnet, and it will use the proper chain spec. So at this point, it should be pretty good. It looks nice in the Polkajs. The set of changes that I'm working on right now are to clean up some of the palettes, make sure there are more documentation lines on different structs, and I will probably reorder some data structures. And after that, Leo can basically update all the mappings that have changed on the front end, rename everything to the subspace, and we'll be good to go, I think.
Awesome. That's an amazing amount of work you've done in the last week, Nazar. So do you think like today or tomorrow you'll have this stuff ready for Leo to go? Like how much longer do you expect you'll need for Polkajs?
We can already start. I think I want to reorder things in the palette feeds. I want to have create extrinsic before put, like in chronological order how it happens. And also there was a typo in the error event, unknown something. So I renamed that, so just 2 changes. Nothing major.
Okay. Well, yeah, I think otherwise we should just freeze feature additions until after the offsite.
I think there will be quite a bit of work for Justin to update the Notion pages. There are many and lots of instructions there. So yeah. I actually assigned him to the pull requests as reviewer, where I did some relevant changes to the readmes and stuff. So he's aware.
Okay. Okay. So so basically, Justin is depending on this to get the testnet actually running. Leo's depending on this to get the Polkajs up to speed, but not necessarily blocked. And great. So do you expect that you would have any time before the offsite, like maybe 1 or 2 days to help Serge with anything on the relayer, like maybe backing up of the Kusama blocks or something like that?
If there is something that is really parallelizable, maybe. It's not like I don't have anything to do.
Okay. Okay. All right, we'll talk about that when we get to the end.
Right, and I actually have 2 other things that I will not present. I just mentioned. So you asked me to look into the EVM versus Inc versus EWASM comparison. I watched a few talks about EWASM. It seems to be originated at the Ethereum ecosystem. They basically explore what they want to do with Ethereum 2.0, where they have stateless smart contracts and they want high performance, they want high reliability. And there was this like long-standing project, I believe it's like from 2016 or even earlier, that was experimenting with different interpreters, different compilers, doing different benchmarks. Basically, the consensus across the ecosystem seems to be WASM is the future. It's just not entirely clear what implementation will win and to what degree it will be compatible with EVM. Yeah, so I don't think EWASM is at the point where it's production ready. I'm not sure Inc is either. But it's kind of clear that pulling EVM is like legacy basically. It might help us with some smart contracts, but it is less secure. There are like food guns that just don't exist in Rust. And I saw some of the more recent presentations about Inc, how you can basically have one smart contract and another smart contract, and one is calling the other. And you can in Rust have like a method that appears on a data structure which has the signature of that smart contract. So you have like complete type safety across the whole thing. It's kind of amazing how it works. And some of the features they wait from the Rust upstream is to have attribute macros on the whole module. You can like put it at the top of the file, and everything in the file will be processed by the macro. So you can do lots of different syntax additions, which wouldn't be possible otherwise. Like right now, you have to annotate every single like method or data structure, but that way you can like write basically pure Rust as you would otherwise, and it will be a smart contract. It's pretty amazing. And you also have ability to use all of the like regular debugging tools in IDE and everything with those smart contracts. It's not something exotic. So in the end, WASM has much bigger like ecosystem essentially. Like every browser supports it, every big corporation supports it, and Rust is also pretty heavily backed. So it's just a choice between eWASM and Ink, and it seems to me that Ink will be much better integrated with Substrate, especially. That would be my educated guess at this point. Not like I wrote anything either of those. Well, I wrote some Solidity back then, but very little.
When you said Ink is not quite production ready, what's left to be done?
I feel like it's still in this kind of experimental state. When someone asks them, what about cross smart contract communication, like XMP messages between different chains, they just close their eyes and like at some point in indefinite future kind of response. So they still actively change it, but it's maturing. For
but
sure.
At least within a single substrate chain, it should be ready to go.
Yeah, I think it might not support like some of the more advanced use cases, but for most people, it should already be sufficient that we should be able to upgrade. And it's like from the parity guys, so it will work well with Substrate, that's for sure. That's what we want. Don't really want to maintain WASM runtime from someone else.
Have you played around with Ink at all, Serge? Yeah.
Yeah, I walked through this. They had a tutorial, like a webinar or something. Yeah, I tried it. But I think after that they released a new version, so a lot of things might change.
It's like with Frame, everything is different.
What was your impression of Ink coming from a Solidity background?
Well, definitely it feels better than Solidity, but yeah, I tried this simple use case. I think it was just simple ERC20 token, so pretty basic example, and it was okay. But yeah, real use cases, they want more, right?
Mm-hmm.
Well, ERC20, to be honest, is a pretty popular use case nowadays. So
okay, cool. Did you do any? Or sorry, go ahead, Serge.
I know there is a team in Kiev actually. They're called Super Colony, and they work on Ink. In like they cooperate with Parity, and they released like a port of Open Zeppelin smart contracts for Ink. So basically, you can
Nice.
use those pieces to combine into what you actually need.
Have you met with them in person, or you're just familiar with their work?
I used to work with some of them in Ethereum.
Okay. Oh, so these are your old buddies from from when you guys did all the ICO stuff back in 2017?
Kind of buddies, yeah. I left, so
okay.
Yeah.
Cool.
The other research I did was on the palette vesting. Basically, there are two slightly different implementations. One is from Parity, from the official set of palettes, and the other one from Orml. I believe the one from Parity is like continuous issuance, and the one from Orml is basically every X block you have a chunk, so more like monthly schedule. So we can basically use either of those, and it should work. The only concern is that it is obviously tied to blocks and not to dates. So in case we start like the chain, we need to predict what will be the block production and when we need to do something in terms of blocks. And then if we restart the chain, then we kind of need to offset it somehow. I don't know how it will work if we need to like reset the testnet or something. We cannot basically hard code the dates in the code. We need to like recalculate everything in terms of the genesis start and how many blocks it will be in the future. So that is the only like unsolved for me question. Otherwise, nothing super crazy. Just have a list of things, a genesis, and that's it.
Okay. I think we're probably going to prefer the ORML version since it is more in line with the actual vesting schedule in our contracts. And I imagine that's going to be lower overhead on the runtime as well.
The only concern there that I have is that it might use stable versions of Substrate, and we are like on the bleeding edge of the master, so we might need to like copy paste and maybe modify it slightly. I'm not sure what their policy is. Maybe they are tracking upstream, but this is something to keep in mind if you are using them. Even if they are using upstream, then we will have to be tied their commits of the parity substrate. We cannot use upgrade arbitrarily, basically.
Okay.
Just how it is.
Makes sense. Okay, cool. Any questions for Nazar from his updates? Okay, Ozgun, do you want to go next?
Yeah, sure. But after Nazar, all the things I've been doing it will be look so insignificant and small. So, but let's go. So, by the way, don't expect too much code because after transitioning into protocol engineering, after GPU coding, the transition phase is taking a bit of time, but I'm getting there. So let's go over the commits. By the way, this is on farmer lib. This is a branch at the moment. No pull request has been done. I have deleted and recreated this, I believe, 2 times since lots of updates were coming to main, and redoing them from scratch was easier than rebasing it. So let's start from here. Actually, we don't need to go over the commits. We can just see the whole file changes. Let's do it like that. Okay, we are in Farmer, and now we have a library, a main, and a common mode. Of course, the name will change for common mode. It's just a tentative name at the moment. And let's start with main. So basically, it uses the common mode, and it uses erase plot and farm caller from that. And this is not being changed. And inside the main, we parse the commands. And after parsing the commands, if it's erase plot, we call the erase plot function. And if it's the farm, we call the farm caller function. And that's all. It's a very small main, as it should be. And let's go to the library, and then I will show you.
Sorry.
Yeah, sure.
Farm caller. What is that? What was that called before?
It wasn't called anything before. This is the new function. Previously, we were calling get path with custom path, and then if it was giving a correct path, then we were using this result to call the farm itself. So right now I functionized it, and let me show you real quick.
Okay, just my basic feedback would be that name is confusing. We might
you are right.
Come up with a better name.
Yeah. But it's just doing this. So it gets the path and calls the farm again. That's all. Again, this is the namings will change. Lots of things will change. This is just the tentative working phase. And inside the library, the comments are same. This need to change as well. Again, as the public interface, only these two functions are meant to be public. Later then, as we discussed with Nazar, we will give another additional interfaces for the farmer to be able to, for example, provide their own identity and access plotting and farming separately. So these will be done. And inside here, there were previously a folder called comments. Now it's not there. And there is a new file called erase plot. And other than that, most of the things are not changed, at least not in a significant way other than refactorings. So in erase plot, we have this try remove function moved in here. Previously it was on main. And this is only being called inside this erase plot. And previously this was inside of this function, was in main. So it's functionized. Other than that, yeah, like small changes, like removing the duplicate use things, and I don't think there's any other thing. Yeah, that's all. The next steps would be implementing channels for two things. One, communicating with the desktop farmer application for both sending messages and receiving. And this is for, again, for two purposes. One, for informing the user what is happening on the background, and also to receive kill signals so that we should be able to stop what's going on whenever the user wants. And after that, I'm gonna abstract some things from the repository. For example, the identity part will be put in a struct and some other things. So this will change a lot, I believe. Also, both main and lib may change. But at the moment, this is what we had turned into a both library and main. And currently it is working, passing all the tests. So the new things I mentioned will be implemented. And currently, this is my progress for the coding part.
Do you have any feedback, Nazar, or have you already had a chance to discuss that with Ozgun one-on-one?
We discussed some of it.
Okay.
Should I click stop sharing?
Hold on just a sec, Ozgun.
Yes,
So two things. Are we tracking any of this on a board right now?
no,
Like on the form,
yeah,
protocol board. Okay. So that's okay. We haven't asked you to do that. So it seems like the scope of this is getting big. I just want to make sure that we've got a plan here on how we're gonna attack this. So so all the things that you just said, let's capture those as tickets on the board,
Sure.
and start thinking about priorities of how we want to do this. One thing that's coming to mind for me, which might be we might want to think about doing, is so we're talking about this public API, and we said, you know, we'd like to eventually have this public API that does A, B, and C. And it might be better if we try to define that public API first, like what the end goal, like not even in, you know, not even the code, like not writing any code, maybe just defining the interfaces for it, for that public API, like what are the signatures of these functions? Because I imagine that that will be contentious what this public API should be, and it might take the three or four of us working together on this for a little while until we finally arrive at a public API that we're satisfied with. And then once we have that public API defined, then start working on the code. What do you think, Nazar?
Ozgun wouldn't let me lie. I actually said the same exact thing in the morning. Define structs, define public API. We will figure out how to implement it later.
Yeah.
Cool. Well, I'm glad we're on the same page there. So do you have the bigger picture, the problem in your mind, Ozgun? Do you think you can define that public API, or is that like a group project we need to work on together?
Not yet, but Nazar helped me a lot on that today. We worked over the repository for a high-level summary. It's coming more together for me, and I think on the tomorrow I will revise it to myself and think about this problem specifically. If I can come up with some ideas, I will let you know. Otherwise, I think if we have time, we can discuss it on the offsite.
Yeah, definitely. We will discuss the offsite, but hopefully we'll have a draft API that we can review by that point, and we're not going to be starting from scratch then. And I think we can also discuss this on the farmer call on Wednesday, or I mean on the call we're going to have on Wednesday morning. We can have a component where we can talk about this API there too.
I'm not part of that meeting, but I can join for this week if you want.
Yeah, that meeting it's in flux. So yeah, we'll definitely you'll be added to that.
Okay.
So okay. So then your next steps are going to be to work on this API and not write any more code until we have that figured out.
Yes.
Okay. Okay.
Okay.
Anything else on Ozgun's part? Any other comments or feedback? Okay, thank you, Ozgun. I know it is a lot to get into this project. This is just the tip of the iceberg compared to the complexity of the Substrate project. So
it's hard, but it's a lot of fun, and I think I will get to it. No problem.
Great. Okay. Okay, Serge. Do we even have any updates to the palette feeds, or is it just all on the relayer that we've been updating things?
Yeah, I was mostly working on relayer. No, nothing on palette feeds. Only what Nazar has shown, but not on my
Feeds
side.
is perfect as it is.
Okay. Okay. So let's just recap what like your immediate priorities are right now on the relayer, and then kind of what's left. Maybe actually, if you want to pull up the board, maybe that would be helpful. If you want to share a screen and show the board, and we can just kind of review progress there quickly.
Yeah, I am already sharing it.
Great.
So yeah, I've been working on this one and this one too. So these two in progress are still in progress. And yeah, these are the available options.
Okay. So I think we can, like you said, we can freeze the blocks as binary for now. We can come back to that. That's an optimization. So your focus right now is really this relayer resync process, and you said that's going to take you about 1 to 2 more days realistically to have that working.
I think so.
Okay. And then after that, I mean, most of these look okay. So the block size limit, put multiple, which we might not even need because we might be able to batch transactions. So the big one really is the backing up Kusama locally and using that as the input for this on Genesis startup.
Yep.
Okay. It feels like that is something that could be done in parallel if you had a little bit of bandwidth to look at that, Nazar.
Probably.
Especially since that integrates so closely with like the Genesis setup that you're already working on. You know, so if we have like, because we have this block production time problem as well, right? Where we have to like have fast block production while we upload all this initial data, and then go back to like a normal block production once we open up the network to other nodes after this seeding process is complete. So it does actually feel like it might, that's something that you guys could sort of do in parallel, or that you might even be better suited for some of those tasks given how it interacts directly with the consensus and the genesis process. Okay, let's see. Let's see. So today is Monday, but it's like Monday night for you, Serge and Nazar. So that means realistically we've got like 2 more days.
Also, sorry to interrupt. I might fly to Barcelona on Wednesday because there are no tickets for me for Thursday.
Oh, you might have to leave a day early. Okay.
Yeah.
Well, cool. That means you can just work on Thursday instead. I'm joking. All right, we'll figure it out. What time would your flight be on Wednesday?
It's not clear yet.
Okay.
We're discussing. I will have a call with Courtney after this one.
Okay. So yeah, as soon as you find that out, let me know. What I'd like to do is, since we can't have the relayer call on Thursday, I'd like to do it on Wednesday instead, at the time when we would normally have the farmer call. So we're just gonna like not have the farmer call this week and do the relayer call instead, but obviously that's, or the storage API call. But if you're on a flight, that's not gonna work. So so let's see if that'll work with your schedule. If so, we can do it then. And I would like just to have a chance to go through the relayer in more detail one more time before we go into the offsite. I guess the other alternative is we could do it tomorrow. We could do it on Tuesday, and then we could do Leo's call on Wednesday on the front end side. We could just flip flop them this week if it's gonna conflict with your flight.
Sorry to interrupt, but wasn't Leo was flying also in Wednesday? Am I remembering it wrong?
Wednesday night, and he's closer to my time, and we have it on Wednesday morning, so he should be fine. He's like 4 hours ahead of me. I think 3 hours ahead of me. Go ahead, Serge.
Yeah, I think I will update you after I have details from Courtney. Yeah.
Okay. Okay. So I guess in the meantime, let's just focus on trying to get the resync working, and then hopefully we'll be able to parallelize a little bit of the initial sync with Nazar and adjust our meeting schedule so we can have a more time to sync up on that in detail in the next day or two.
Okay.
Okay. Cool. Anything else we need to discuss? Okay, if you can stop recording, Ozgun, please. Thanks everybody for watching. See you guys next week.